So let's start talking about this free response question. This is the last one that we're going to do in class to prepare for the test. Most of the time, most teachers will only do one free response question per unit. I don't like that. I always want to do two, but I also gave you another four to help you practice. I will put the solutions for those four, because they're all released AP free response questions, on Schoology, so you can check yourself if you want to do any of them before tomorrow, so that we can go over them. I will say, a bunch of us are not going to be here, but I'll still record for whoever is here and talk about the questions that you have. But that way you can check your responses, right? And so you'll be able to check your stuff. Okay, so we have a local school board plans to conduct a survey of parents' opinions about year-round schooling in elementary schools. The school board obtains a list of all families in the district with at least one child in an elementary school and sends the survey to a random sample of 500 of the families. The survey question is provided below. A proposal has been submitted that would require students in elementary schools to attend school on a year-round basis. Do you support this proposal? Yes or no? The school board receives responses from 98 of the families, 76 of the responses indicating support. Based on this outcome, the local school board concludes that most of the families with at least one child in elementary school prefer year-round schooling. What is a possible consequence of non-response bias for interpreting the results of this study? Ian, you had your hand up first.
I wrote that a possible consequence of non-response bias is that the results possibly overestimate the true percentage of families who are in favor of year-round schooling.
Okay. Anything else we could add to that?
I just said not represent the population.
So notice, and this actually goes back to, and this is why I want y'all to look at these, it goes back to one of the AP exam tips. We can't just say it doesn't represent. We have to do two things when we talk about bias. What are those two things?
Content.
You have to talk about over or underestimate. You do need context, but there's also another thing.
How the people responded.
So how would this sample be different, right? So yes, the sample is different, but we also need to talk about how would maybe the people who did not respond possibly be different from those who did. I don't think that this actually goes into that. So clearly links the effect of non-response to biased estimation by explaining why the population support would be overestimated or underestimated. That kind of refers to it. It's been more recently where they've really harped on, you have to explain how is this actually causing bias, right? So which people didn't respond?
People who didn't want year-round schooling.
So maybe the people who didn't want year-round schooling, but there's something else.
Didn't care as much.
So the parents who don't care as much, right? Maybe they're not as heavily invested in school. Maybe they're working too much. And so who is responding? The parents who are
Strongly.
Stay-at-home moms.
maybe stay-at-home moms. They don't want their kid at home. Maybe helicopter parents. Maybe in general, maybe people who are super invested in their kids' schooling. So they want year-round school. I don't know if you've ever heard of this, but it's a legitimate issue in education. And so I would be more in favor of something that's closer to year-round. The brain dump over summer break is terrible. And it's especially terrible for elementary school students, right? So parents who are more educated, more informed on that issue, parents who are very invested in the education would be more likely to respond. Or just in general, if you're really in favor of something, you're more likely to respond, right? Notice we're talking about how the sample that we have is different from those we didn't collect data from. And so that's what you need to think about with bias. How is the sample we have different from the data we did not collect? Or how did that bias affect things? And so that's what we need to talk about there. And more than likely, it is overestimating the population in favor of year-round schooling. But notice you could have said underestimating. You just had to justify it. Okay? So over or underestimating.
How would it underestimate?
Like every single percentage what we get response there.
Oh, right.
So one way I would say it, so yes, you're right, but like, again, the type of bias or like how that could happen is, parents who work more have less time to respond, right? And I've always been surprised that parents who work more don't want year-round school, because if you're working a ton, then you have to find something for those kids to do during 2 months of the summer, right? But if you move to a year-round school, then you don't have to find childcare or something for 2 straight months. So the people who have to work a ton didn't get a chance to respond, but maybe they're super in favor of a year-round school because it takes care of their kids throughout the summer, right? So there's that. How could it underestimate? That's how, right? All those people really want
Okay.
schooling. Okay, how we feel about A? Does that make sense? How we talk about the, talk about how the sample is different, or how the results were affected, and over or underestimate. You gotta hit both those. Okay. B says, and what was the P here? So notice, okay, so it does talk about a reasonable consequence in the context of the study. So can't just say the population is different. You gotta have a context. You have to have something that is reasonable. So any of those things we talked about would be reasonable. Okay. B says, someone advised the local school board to take an additional random sample of 500 families and to use the combined results to make their decision. Would this be a suitable solution to the issue raised in Part A? No. If you take 500 more people and you still have a high non-response, it's still going to be the same problem, right? Even if you collect data from 500 more people, you still have 400 something you didn't collect data from, right? You still have the old non-response, right? So taking more samples doesn't fix non-response. In fact, I need us to hear very clearly on this. Right here, when we did our subjective sample, and we need to remember this, even if we had taken 100 more samples, your eyes are still drawn to which set of words? The bigger words, right? So taking more samples when you have a biased method does nothing but reinforce the bias. Taking even more samples, if you have a biased method, does nothing except reinforces the bias, right? So if you say no, taking another sample will not solve the problem of bias, because we would still have the original bias, or you would continue to perpetrate the problem, then that's all you needed to talk about there. But that is something you need to recognize. A biased sampling method, and that's one thing I need to be clear about, it's not just one sample being bad, it's them consistently being bad. So a bad sampling method will still result in bias. Okay, so a bad sampling method will still result in bias. Does that make sense for me?
Oh, yes.
Sweet, thank you. All right, C. So this is one of those things, each different type of bias needs their own solution path. I will say this, if you have response bias because you dressed up in a fireman's outfit, in that case, you need to take off the fireman's outfit and to try to genuinely get honest responses. If you ask a question in a way to push someone to think a certain way, then you need to reword the question. Like in this problem, did they word the question in a way that might influence responses?
No.
I didn't think so. It was just, do you support it or no? And like it was very straightforward, it was very plain. So there's no response bias. But if there was, because of the way the question was worded, we would need to reword the question. If we had bias because we had bad sampling, right? Not random, we'd have to fix it that way. So I don't think I've directly talked about this, but it's something we need to think about. How do you fix non-response bias?
That's
Change
a way of.
We're talking all over each other. Phoebe, what were you saying?
Like to try to like contact the people that didn't respond or get them to respond to someone.
And I think it talks about that in the book. I could be wrong, maybe. But Emerson?
You could also just change the way that you did the survey.
Okay, but you would still, so like they still didn't respond yet, right? So what do we, so we may need to change the survey and then what? What did Phoebe say?
Contact.
Contact them again, right? So I'm 100% with you, right? That actually is a good point. Never would have thought about it, so I love that you said it that way. And that's another thing that they would probably accept if you explained it that way. So yeah, just as an explicit description of a reasonable strategy for reducing non-response bias in a new survey. So change the way that the survey was given to them. Maybe it was paper originally and you had to mail it in. Well, no one's going to be mailing anything in anymore. Maybe Now you send it out digitally on a phone or on the school website. But definitely what Phoebe said, you have to follow up. If you don't get responses from people, you can't just let them not respond, because then you don't know how they feel. You have a biased set of data. You have to follow up as much as possible, okay? So make sure you are paying attention to that idea of, if you have non-response bias, you have to follow up with the people who did not respond and try to get data from them. Now, are you ever gonna be able to eliminate non-response bias? No. But if someone reaches out a second, maybe even a third time, maybe you bug them enough that they would respond. So keep reaching out. Yes, Ian?
What's a good number, like percentage of the sample to where we can just make a true estimate?
That's a good question. There's not a real answer to that. They don't ask you about that on the AP exam, and you have to figure out what's comfortable for you as a researcher. So one, on the AP exam side of things, don't sweat that detail. For me, I would want at least like an 80 to 90% response rate, I would think. The closer you get to 100%, the better. But they also have ways in statistics to account for non-response rates when you get to a high enough level. I don't know that yet, so I don't have an answer. Yes,
I
Fran?
get it partially right when I just said, change a way to take the survey, like just like Emerson said, I do not add it like that. I have to follow up.
I mean, what does it say? So you have to provide an explicit description of a reasonable strategy for reducing non-response in a new survey, or by following up with families. As it just says or, so it's one or the other. So that sounds like an E to me, right? That's fair. It does say explicit description, doesn't it? No, yeah, you need an explicit description. I mean, I would say that, well, they didn't tell you how the original survey was sent out, did they?
Yeah, but I kind of explained in detail that.
Yeah, so I think as long as you say, hey, I'm gonna change the survey format so that it's easier for people to respond, that'd be explicit enough, I would think, okay? Yes? So you could try to do a census, but here's the thing, what is a census? It's when you collect data from everybody, from the population. Now, that would completely eliminate bias, you wouldn't have to do any inferences, but at the same time, if I have 400 parents not responding to a sample, right, to a survey, I'm probably not gonna get everybody's opinions in a census.
And if they don't, they get fined and their kid goes to the summer school.
You know what, that might be an explicit description that gets you credit. I don't know that I would do that, especially to elementary school kids, punishing the kid because of the parent. We gotta move forward in a second. Charlie, what you got?
I feel like that response would introduce a new problem since they're likely to say yes in order to be taking.
That's a possibility. I don't know. I think, I don't know necessarily it's possible. Raina?
In B, you need to explain why it is not, I just said it doesn't solve the problem. Is why doesn't it solve the problem?
Let's talk when we head to lunch so I can look at it quickly before I'm trying to visualize it. I need to look at it. Alright, so here's the DYU. We finished through the the false statements yesterday. We finished through the multiple choice. I recorded it, uploaded it yesterday. I passed back your DYUs. Leah, take notes on yours to help improve your understanding for that test on Monday. But let's look at the free response on the back, okay? So, an experienced server at a restaurant wondered if suggesting a specific dessert to customers would increase the average total bill and therefore tips. For every table in one shift, the server tossed a coin before approaching the table. If it landed heads, no suggestion for dessert was made. If it landed tails, the server made a specific suggestion for dessert. The server found that tables who were given the dessert suggestion had a higher average total bill, and the difference was statistically significant. In reading through y'all's responses, y'all did a great job of understanding that statistically significant means that the difference Now, we'll add some language to this that some of y'all might have had, that might not have had, so pay attention to this. Difference in results was so low, or the probability, I should say it that way, probability of a difference in results was so low that it probably was not by what?
Chance.
Probably not by chance. But what did a lot of us forget?
Context.
Yeah, guys, you cannot forget on the AP exam to include context every single time, right? So the probability of what results? The probability of the higher bill due to a suggestion for dessert, right? So the probability of, or the likelihood of a higher bill, or such a difference in the results of the bill, I should say, is so unlikely to happen by chance alone that it probably wasn't chance, right? You gotta have context somewhere in there. So context plus what a statistically significant event is, which that's a terrible wording for it. So it's probability of seeing such a difference, or what? We got a detail here, or more extreme, right, in results. So the probability of seeing such a difference or more extreme in results was so low that it probably was not by chance, right? But put that context in there. Okay, make sure there's context. Madeline even included a small note that we want to keep in mind, that what's the probability marker that we want to consider? Less than what percent?
0. Wait.
5% chance. So remember, it's not that it's impossible. Remember that. It's not that it's impossible. That'd be a probability of 0. But there's a less than 5% chance of it happening. It's so unlikely to happen by chance alone. I don't think it was chance. I think there was something else at play. In this case, and this is where the majority of you really need to pay attention to your details on B, because a lot of us said something to the effect of, I don't want to grab anyone's paper.
Oh, you can grab mine, don't worry.
Okay? Suggesting, this is good, this is exactly what most of us did. Suggesting a dessert
I volunteer as tribute.
does increase the final total bill. So this is actually very, very close to what we want, and somewhere a little bit further away from what I wanted, or what we need for the AP exam. What is the key language, though, for experiment that we don't have here? Causation. Suggesting a dessert does cause an increase in the final total bill. If you don't have that clear language of cause, it's more implying that there's a what? A correlation. Now, they may accept it at other times, but I want you to be as clear with that language as possible about causation.
I got a phone call and
Right, because you just said it will result in an average total billing increase. But just significantly, but just saying it results in that, an increase in the billing is the idea of a correlation. It's not necessarily guaranteeing causation, so you have to be explicit and include that detail of causation. So the suggestion of dessert causes an increase in the bill. It's implied, you just have to remember for the AP exam, it has to be explicit. Yeah, that's the big thing there. Yes, Raina?
Can we say that you can establish causation is when the result is
Statistically significant? In an experiment, yes, but also again, you need context.
Yep.
Yep, you need context. But again, I would just say it that way, suggesting a dessert, or something along these lines. Suggesting a dessert does cause or causes an increase in the final total bill for customers. Okay, so make sure you are explicit with that causation. Any other questions on 13 before we continue? Okay. So, do not forget, experiments, all about some causation. Okay, number 14. I think for the most part, we were pretty good on explanatory versus response. It's more the confounding that we need to talk about. But don't forget, because there was a couple that missed out on this. Notice wearing fitness trackers over a period of 2 years and attending regular health check-ins. What is that? That's not a variable. What is that? Not the treatments.
And that's just the method for people tracking.
That's the method for,
Recording.
this is how they are measuring. Specifically measuring that BMI, right? Like, or measuring the response. And really they get the BMI at the end, but they're just kind of tracking them this way. Those aren't variables. Everyone is wearing a fitness tracker. Everyone is having regular health check-ins, right? Yes, Ian.
What was the explanatory variable? I forgot to write it.
I'll have to go back. Oh, did you? Did you?
You put like the blank line because I didn't write it.
Okay, so explanatory. So first off, what are they measuring? BMI. So at the end, they're measuring the BMI, so that's my response, right? So the response is the BMI scores, right?
Is it better to say just the scores of BMI or have lower BMI scores?
Doesn't matter, either one's fine. Explanatory. So Ian, what is explaining those BMI scores?
That fitness. Wait, that fitness in the morning. Said overall BMI.
So exercising early in the morning versus later in the day. Now that's closer, I will say, to the treatment. So what would be the explanatory? What's the factor? The
Time of
time of exercising. Yes. Time of working out. Notice, why did I say working out in the morning versus working out in the afternoon are the treatments? Because those are the levels or the values of the explanatory variable, okay? So the explanatory variable is the time of exercising. I accept it if you put the treatments, but the variable, the factor, is the time of exercising. And that is explaining the BMI scores. Okay, so for anyone who missed that, does that detail make sense? Okay, all right. What is a possible confounding variable in this case? There's a couple of them. What you got?
More motivated people will work out in the morning, so motivation.
So motivation, get up for your day. What is another confounding variable you could have, Charlie?
People who are working out early in the morning are likely doing other things to stay fit, getting a lot of sleep.
Okay. So maybe generally more health conscious. Okay, anything else?
Types of people like really overweight, skinny, breaking away.
Okay, so starting BMI might be a confounding variable, very much related to the BMI in general. Emerson?
What workout they're doing?
Okay, so the types of workouts. So all of these are valid. There's probably others that I'm not thinking about. Does anyone have anything besides that, Lorelai? Age, yeah. Okay. Diet, I would have said health consciousness. That fits under there as well. Same thing. Gender, okay? Now, I will say this. The one thing I would point out is some of these aren't as easy to make a correlation or a relationship to the explanatory variable, but I mean, you could very easily say it is possible someone with a higher starting BMI typically works out in the afternoon, right? Because they're just not as motivated to get up, and so they have higher BMIs at the end of this, or something like that. But don't forget, because this is what a lot of us forgot, is how does this lead to confounding? You have to explain how does this variable do what? So it relates to the explanatory and predicts the response. Not just relates to the response, but actually predicts or explains the response as well. Because I want to know, how does this explanatory explain the response? But if I've got another explanatory variable that's not of concern, that confounds the results. Okay? So you got to show how it relates to the response variable and, or to the explanatory and predicts the response. Again, I will point out some of these things, like that was a huge AP exam tip. We've got to be paying attention to the information in the textbook because reading it, working through it, and writing it, like all those things together, what we do in class and what you do outside of class, are heavily related to your mastery of these things. Okay, any questions about 14 before we move to 15?
Wait, so cardio doesn't, strength and conditioning lowers your BMI faster than cardio? That's what you wrote on mine.
Yeah, so if you didn't know that, strength workouts builds lean or can build lean muscle mass, and so when you have a higher lean muscle mass, you actually burn calories at a higher rate because the muscles burn calories faster. Cardio, just for the most part, burns the calories while you're working out. And so if you want to get cut, if you want to get ripped, one, you got to change your diet because apparently all that stuff is made in the kitchen, is at least what I've heard. But two, you got to focus on strength conditioning as well as cardio. You need both of them, but the strength is really by creating that lean muscle mass. It makes the biggest difference. Yep.
I think we should crunch one day and like test that out.
Do what?
Right.
All right. So we have a recent study with 60 middle school
Yeah.
students,
No.
and it was conducted to try to determine if reading comprehension was affected by the mode in which the students were reading. Half the students were randomly assigned to read a passage on printed paper, other half got a digital device, and then they were asked to complete a reading comprehension test and scores were recorded.
Yo.
So why is this an experiment? One thing I want to point out is this. I understand why we did this. A lot of this talked about randomly assigning treatments, okay? But here's the thing. You need random assignment. And so I didn't count off or anything, I just made a note of this. You need random assignment for a good experiment. But an experiment only needs an assignment of treatments. If you don't randomly assign, you don't reduce the effects of confounding. But as long as you assign treatments and then what? Compare, you have an experiment. Yes, Star.
So, can we write randomly assigned?
Yes, you can write randomly assigned,
So I can
but,
write random assignment of treatment.
yeah,
Okay.
like, I tried to make the note, like you'll notice, if you put randomly assigned treatments, you got an E, okay?
It's funny.
The big idea is, though, I need you to understand, it's just the assignment of treatments that makes an experiment. It's just the assignment of treatments. What does the random assignment do? Reduces confounding, right? It distributes those confounding variables evenly. All right, we gotta finish this. Experimental units. That's who the treatments are applied to. That's the students.
The middle schoolers.
The middle schoolers, okay? Treatments, those are the,
Print and digital.
okay, so the digital
Reading.
versus print reading, okay?
Yeah, that was so.
Wait, so I got it wrong because I said and.
Yeah, I mean, I don't know if that's why you got it wrong, I'll check in a second.
No, I put.
All right, describe a process. Hey, guys, most of us did pretty well in this, but what do we have to have when we describe a process? Label, generate, assign,
Compare.
and compare. And I do recommend putting that detailed compare. You'll notice if you didn't put compare, I didn't count off, but you do want to compare at the end. So label all of the students 1 to 60 with a unique number. Generate 30 unique identifiers from 1 to 60. Assign those students to one of the treatments. The rest get the other treatment. Okay? D, sorry I'm moving quickly. I'll write up here so you can take a picture if you need to afterwards. But D, block on grade level, right? That's the big idea. Block on grade level, then randomly assign treatments to each half of the grade level.
You gave me a, tell me, you guys fly?
That's a little weird. You're talking about D as a four.
We all have our own Noah. All of these, yeah, and I share with us.
Sure.
So, all, I'm
Yeah, she said that to them. Yeah, so she.
Passed out, and I'm going to talk about it before we start Unit 2. It is your first project for this class. So 2 things with it. One, you are going to have a test, obviously, on Unit 1, okay? But this project is probably more informative of your preparation for the AP exam than even the test is. Because what I've done is I've given you 2 different studies. One of them is an observational study. One of them is an experiment. And you have to identify which study is which, and you have to identify how the researchers either reduced the bias or reduced the confounding, what elements of the study they took advantage of to reduce the effects. Now, one thing I found last year is it is a lot if you try to do it all on your own. So this is going to be a partner project. The expectation is that each of you do a write-up of one of the studies, and then you read each other's to help give feedback and improve it. Now that's just the rough draft. There will also be a final draft, okay? So, what?
Oh, I'm like, I didn't even say rough draft.
So there is a rough draft, and you'll notice I took off what day it is due because there's 2 thoughts that I have. It could either be next Friday, which gives me a chance to read through it, give feedback over the weekend, and return it to you by Monday, or I can let y'all turn it in on that Sunday and take the week to give you feedback and give it back to you before the next weekend and before your final draft. So, I will randomly assign groups, because that's the only way to do it fairly, as we have learned this unit so far.
Okay. Give each student a unique identifier, 1 through 13.
14.
14. Randomly generate 14 unique numbers. Randomly generate 2 unique numbers, 1 through 14. Finally, select those individuals that correspond. Select those individuals who are given a number 1 to one side of the group. Give those who are given a number 2 to be a match pair.
But except it's not really an experiment, but very similar idea. But, so again, here's the thing, legitimately, you need practice with multiple choice, you need practice with AP free response questions, and so you will have a test on that on Monday. But this writing does 2 things. So one, I always want to emphasize this. We're not just learning this for an AP exam, we're learning this for the real world. And so these 2 articles I actually handpicked. This is not a project I've seen anyone else do, but I think it's been very informative for my students overall. And so one, what at least Serena, Peter, and Jaden said is this writing assignment helped them a ton prepare for the AP exam, AP Stats exam, but it also helped Jaden in his AP Psychology class, because literally their studies, they said it helped them a lot even in their AP English classes, because there's writing and there's feedback, and it gave them more stuff to write about in those AP exams, okay? So this project is multifaceted. It is also prepared to help you be better for real world, not just an AP exam. So it's a lot, but I need you to understand, I'm going to give you all the support you need to be successful, and I'm going to help get you there, and we're going to do random groups in a second. Again, I'm taking a huge load off of you because I asked everybody to do it on their own last year.
Oh.
Yeah, so they had to analyze 2 studies completely on their own, no partners. So, yes, Charlie.
Are we handwriting our papers, or do?
I want you to type it. There's 2 reasons for typing. One, it's easier for me to give you feedback and for you to do a final draft if you just have to edit rather than completely rewrite.
Oh, yeah.
So, I'm all about the typing life. Second, I've read Star's handwriting and I can somewhat do it, but I'm going to do it to myself completely. So, it also allows y'all to collaborate more easily. So I will point this out, obviously not with your TCSS email, but if you have a Gmail account or something, you can do a collaborative Google Doc where you're both typing on the same document, really useful. I think you can do something similar with Microsoft, their online Microsoft thing is not the most useful.
Word.com.
Anyways. Alright, so read through your studies. So here's the question. Do you want it to be due next Friday or the following Sunday night?
Sunday.
Friday.
Raise of hands if you want next Friday.
Oh, word.
Raise your hand if you want next Sunday night, so you have the weekend.
I think that was biased.
Okay, there we go. I didn't reword that right, so that you had all the information. All right, so if you want to write in there, so next Sunday is August, or next Friday is August 29th, so next Sunday will be August 31st. So it'll be due on August 31st by 11 p.m. And I will generate random groups sometime in the class. And fun fact, Ian, there is a random team organizer that I'll just use online, which is way easier. But I also respect the hustle. Yes. So this next unit's a little bit longer. There's a few more things involved in it.
2 pages longer.
Well,
Light work, no reaction.
some of the sections will be shorter, like you won't have as much to write in there. So there's your Frere models for this unit. I don't have your proficiency scales for this unit yet because I want to go back through them, okay? Now I apologize for this. This is unit 2. Yep, this is thick.
Actually, I need to.
But a lot of it is practice. Some of us are already not doing the practice, so you'll be fine, Star. But it's there in case you want to do the practice. I know Ethan literally put on his survey that he likes practice for, or a few practice problems each time. Here's the last page. So, there's always that option of studying.
What's her name? What's her name? One question.
All right.
That's all I know.
Aldrich?
Oh, wait,
Yeah.
My God.
I love her, but she's
Yep. Okay, so I will point this out, and I need y'all to hear me on this. The packet that I just gave you is your next unit, right? This is part of the reason why I have y'all doing those Frere models, to build a summary instead of having to lug around your textbook or look through all these notes, because let's be real, you're not going to read through all those notes when you're preparing for an AP exam. If I were you, please hear me clearly on this. If I were you and I start to run out of paper or space in my binder, I might start taking out old units, leave the Frere models and the proficiency scales in there, and as time goes on, I would put the old notes in a special place so you don't lose them, but it's okay if you take them out of your notebook. Yes, Ian.
I didn't get a chance.
Okay. All right. So, Unit 2, which is technically AP Exam Unit 1.
Sorry, but do we, like need regular paper?
No, you don't need notebook paper for my class, like, ever. Like, if you want to take, like, 10 sheets, you might use 10 sheets all year in my class. Bless you and stuff out.
Thank you.
All right. So, right here, we are starting on Unit 2. Technically, Unit 2 is only about univariate data. Any guesses what I mean by univariate? One variable, right? So we're talking about one variable data for the most part. However, I will say the Mathematic has not updated completely to the course and exam description, and they still have 1-2 variable idea in this unit. So I went ahead and rolled with it. But you'll see it on the Frere model. There's a note that you actually have to go to unit or section 2A. I don't know why I'm walking over here. You have to go to section 2A at some point to do some of the stuff. Where's my presentation remote? Haha, someone tried to hide it, aka myself. So, how are your favorite classes related? Is your favorite class, elective class, associated with your favorite core class? We asked a group of students what is your favorite elective class, but forgot to record the number that said PE. Now, first things first, I want to address this to always bring this back. What type of data are we looking at here?
Categorical.
Andrew's like, maybe quantitative. Why do you think in quantitative? There's what? There's numbers. I need you, and this is why I asked this question. I need you to remember though, the question is not if there's numbers or not, the question is what type of response is it? So if I ask you, Andrew, what is your favorite elective class, and you give me one of these responses, that response is a category. You're always going to have numbers in statistics. You always have numbers. The question is the response a number or is the response a category? And when I say number, I mean a quantity. I think Raina was saying something to be counted or measured, right? A quantity earlier. All right. So from here, we should, for the most part, hopefully be able to breeze through this first page because we've already addressed a lot of these ideas. What I want you to do is I want you to address questions, 1 through 7 with your small group. So go ahead and start working, 1 through 7. We'll come back together in a few minutes and talk about it. I'll be around.
Identify the individuals.
Okay.
The students.
All right, so a couple of things to look at, talk about, make sure we understand here. So when we say individuals, right, and I will say this, it's not the group of students. Where's my, there it is. Individuals, what do we mean by individuals?
The students.
So it's the students, but I meant just in general, the individuals are the who, not kind of the what. Yeah, not as a population sample, but who or what, right? Okay, so when we say individuals, it's the who or what is being studied, okay? Then we look at, sorry, I'm having to erase this. What were the variables being measured? So what was the variable being measured? So favorite elective class, and the favorite elective class is what researchers want to know. That's one reason I was a little iffy on what. But who or what is being studied, that's the individuals. Okay, the individuals are the who or what is being studied. The variable being measured is what the researchers want to know. I think we're hopefully good with the fact that this is what type of variable. Categorical, okay? Now 4 is where I want to point something out. So a lot of us approach this one in different ways. I'm going to show you what I think is the cleanest way to understand percents in this case. So first off, I was pointing this out to another group, or one of the groups already. So when we say 30%, what does the word per mean?
For 100. Divided.
Divided. So it's 30 divided by 100, right? Literally, if you break down percent, per is division, cent, right, as in a century, 100 years, or the number of cents in a dollar, 100 cents, right? So when we say percent, it's 30 out of 100. And so some of us scaled that up or scaled it down, but what we know is it's 9 out of whatever my sample size is. Notice this isn't population, right? It's just the students, well, depends on how we define it. Could be the population. I really liked, getting back to it though, the way that Emerson approached it. I think, Madeline, you did this as well. If we look at this, and you scale it up, 3 times 3 is 9. 3 times 10 is
30.
So what does n have to be?
30.
If the numerators are the same, the denominators have to be the same. So n is 30. It's not how I would have done it, but it is a very efficient way I would have done it. Here's what I would have done. If you ever have a percent of or a fraction of, do you know what that operation or what operation that becomes? It's multiplication. So 30%, bless you, 30%, same as here, 30 out of 100, or 0.3 of, do we know what the sample size is?
No.
Of n, or times n, equals 9. 30% of n equals 9. Divided by 0.3. So that's how I would have done it, right? When you say a percent of something, that just means to multiply the decimal or the fraction of it, and then set up your equation and solve it out. N comes out to be 30. You can use calculator. You can use calculator on the entire AP exam.
Wait, what?
You can use a calculator on the entire AP
Like
exam.
the Desmos on it?
So yeah, there will be Desmos, and I'll teach you how to use that some, but also the Inspires.
Oh, really?
Yes.
Oh, like the physical ones?
Oh.
Yes, the calculators we have in this classroom. Yes, you can use it on the whole exam. Obviously, we didn't need it a ton for study design, but you can use that on the entire exam. They also give you a wicked good formula sheet that you can use on the whole AP exam. All right. Any questions about this percent question here?
That's 100.
No? Okay. So then, what was that, number 4? So how many students chose physical education, right? So now we can find this out. Notice we had to have the sample size, but now that we have the sample size, we know that there are how many students in PE? 7 students. No, just 7. Just 7.
I'm sorry.
No, you're not.
I'm not.
Anyways, so how did y'all then fill in this? I'm not going to spend a ton of time here on number, was that 6?
I was the one you did that part.
Say again.
I was the one you did that bit, that part there. Music had the most bit, had the most students, so that was.
So it had the biggest angle?
Then tech and except foreign language, but have the same proportion.
Mm-hmm.
And then art and PE was tricky. I kind of figured out that the orange one might be
A little bit bigger.
but I use that for PE.
Yep. That's good. Now, I want to point something out here. You'll never have to do this by hand because I live in the 21st century and I have technology. There's this one thing called Jump. It's spelled JMP, but the company calls it Jump. That does some really, really good. What is it called? Graphs, and you actually can get it for free as a student. And so I'll show you how to download that on. Hopefully, you can download on your iPad. We'll find out. But it's free. You can actually use the Inspires to create graphs. You can use a lot of different sources to use graphs. So we don't ever have to do this. But does anyone have an idea how I could figure out what the actual angle for the music here is?
About 360.
There's something with that.
You use whatever.
And took that 360.
But
980.
Mouse for the same like this or whatever.
You can use the percentage.
Okay,
of
so-
the used by.
I would say there's a lot of different ways to do it, and I do hear some of the ideas going. So I hear some of us talking about taking, say, 360 and dividing it by 30, because that means each individual would be equivalent of what, 12 degrees? That would work. The way I was thinking about it is this. Someone was mentioning a percent, which really all a percent is a part to whole ratio. That's it. So like if I'm looking at music, how many people are in music?
4.
4. In music?
9.
9 out of 30 is equal to my angle out of 360. Like that's all I would do. When we talk about, and so like notice you could figure out, you could use that to equal a percent out of 100. It's just proportional reasoning. You don't have to do that by hand. I just want to point out, yes, 9 out of 30 would equal x out of 360. Find your angle from there. Yes. Okay. So that's a possibility. That's all you'd have to do to figure out angle measure. They don't expect that. I just want to make sure we know how to do that. That gets us through number 6, right? Any questions through number 6? Well, we're on 7, so it's good. All right. So 7 is where we should have started to run into a little bit more issues, because there are some ideas at play in 7 that you may not have studied before. Notice though, what they said originally is there a relationship between elective class and core class? Now I have 2 variables at play, right? Elective and core. So percent of all students who chose PE, how would I do that?
7 divided by 30.
Okay, where did that 7 come from? Because I don't see that in this table.
Because it's 4 and 3 together.
They didn't specify math or English.
Right, but they didn't specify math or English, so 4 and 3, and so the total PE is 7. By the way, I would fill in my totals here. How many total music did we have?
9.
How many total art?
6.
How many total foreign language?
4.
How many total tech?
4.
How many total English?
14.
And how many total math?
12.
Has to be 16, right? We have 30 total. For notice a total down here of 30. So, I'm about to break down some details here because I think a lot of us got these percentages. But 7 out of 30, I will say this, by the way, just find out what that decimal is. What is 7 divided by 30?
Repeating.
About
6.6 repeating.
Yeah.
so 0.6.
Oh, 100%.
Okay? So 0.06 repeating, 7 out of 30. That's a calculator, right? What did you say? What are you thinking?
I thought the total was of all students.
Was it, did you add these and add these?
Oh, okay.
So remember, like, this is just one of the variables, which has a sum of 30, and this variable has a sum of 30. Yeah, so 7 out of 30. So 0.6 repeating, remember how it's out of 100? So that's 6 hundredths, or 6 out of 100. That's just 6.6 repeating percent. Right, 6.6 repeating percent. Just multiply it by 100 if you want to get the decimal version. Okay.
Oh, is it okay to, yeah, what I did was I multiplied
Oh my God.
in advance and I got the result of 70 over 3 and I.
I mean, listen, does it matter if you divide first and then multiply, or multiply and then divide?
No, I was just.
Okay, but I will say this, really quickly, guys. Wait, so 7 divided by 30 is 6%? There's no way. Yeah, what's 7 divided by 30?
Oh, it's 20%.
Oh my God! I'm sitting there going, like, literally this whole time, I'm like, that can't be right.
Yes, it's
Okay.
Just
Was
loud.
it 3 repeating?
Why are you lying? Wait,
Okay.
no, I.
So that would be 23 hundredths, or 23 out of 100, or 23.3%. Thank you, Star, for lying to me.
Just loud and wrong.
Think about loud and wrong indeed. All right, so, hey guys, focus. So, percent of all students who chose PE, 23.3%, or 3 repeating percent. Now, percent of all students who chose math and chose art.
If that is,
Just the art and the math.
that's,
So that's 2 out of 30, which is 0.06 repeating. Okay. Now,
Oh, that was.
what's your question, Lorelai? Did you do it out of 60 again?
No, I did not do it out of 60.
I don't want to.
So you had it right.
Alright, so let me pause and point this out. Because Raina asked about this earlier, I would personally always do a decimal first and then get the percent, because what we're going to do a lot of times in this class is do probabilities, and probabilities are always between 0 and 1. So I would get used to getting the decimal first and then converting it to a percent. It does not matter if you multiply by 100 first, it's just thinking through the future. Alright, percent of students who chose technology given they chose math. So notice, I'm no longer looking at all 30. Madeline, what are you thinking? Okay, so it's only given that they chose math. So do I care about the English people at all?
No.
By English, all I care about are
tech.
math. Specifically, who inside the math?
Four.
Tech. So there are 4 out of 16, which is 0.25.
Just loud and wrong.
Or 25%. So notice, we only want math. Okay? This is what, I'm going to go through all of these in a second, but this is what we call a conditional relative frequency. Because did I care about everyone?
No.
No, I had a condition. What condition?
Math.
Right, this right here is a condition. I'm no longer looking at everyone. I am only looking at this condition. So any guesses what we call this, where we only look at part of the sample, and there's a condition involved?
Single condition.
It's a conditional, which if I give you the proficiency scale,
Condition.
We don't
I would
have
have,
one.
I know, if I give it to you, you would have it. It's called a conditional relative frequency. We don't care about everyone.
No, I was.
We only care about the condition of people who chose math. That's it. Okay? You good with that? Conditional relative frequency. Now, in the one just before it, did I look at a condition or did I look at everybody? I looked at everybody. But at the same time, I looked to see where these two things overlapped or joined together. So we call that a joint relative frequency.
Why'd you say oh?
Break down the words and these things make sense. Joint, that means they join together. Okay, so joint relative frequency, they're joined together. The blue? Well, remember, it's math and art, so it's where the two join together.
What was the frequency?
This one, oh, we haven't done the first one yet. You talking about this one up here?
No, what was the condition of those?
It's when we have a condition, we don't care about everyone, we only care about the math. So when there's a condition, where we look at a subset, and so, let's say that subset for, or condition for a subset of samples. So not the whole thing, just conditional. Now, here's the last one. Now I'm trying to break it down so it makes sense. Here's my original data, right? So for that top one, we didn't take anything from this inside of the table. What do we call the stuff on the outside?
Extraneous.
There's an M word that maybe you talk about with your papers.
Margin.
It's the margins.
Oh.
Yep. So this was a marginal relative frequency. A marginal relative frequency, I do want to point out, does it care about two variables or only one? Only cares about one, right? So marginal relative frequency for one of the variables. So a joint is where two variables happen at the same time. The math and shows art. The marginal is where we only look at one of the variables, so we look in the margins, and then the conditional relative frequency is when you look at the condition. Or you look at that one variable to determine the other probability. Yes?
Are these, this term that we just learned, exists in chart forms, or can we just look at it in other types of graphing methods?
You will definitely see them in other forms, so hold on to these. Yep. So we get the names from a table like this,
Yes.
but we'll see them in stuff called mosaic plots, in segmented bar charts, comparative bar charts, etc. Okay. Any questions about those different types of relative frequency? They click a little bit, hopefully.
Yes.
Sweet, thank you. All right, so now this is the back side, and because we're running out of time, we're gonna have to kind of look at this one together. So how many variables does that table have?
Like
7.
Has how many?
8.
It only has two variables.
2.
What are the two variables?
Math and English.
Nope.
No, it's either
Oh,
upper
upper
class
class or core class.
Core class or elective class. Now, each of those variables has multiple responses or sections to it, but the variable is the thing that can change, right? So the core class can change. The elective class can't change. So core class or elective class, they're both what? Categorical? But Andrew, I got numbers, so why is it categorical?
That's not what you're looking for, or that's not like what you're asking.
I'm not,
Did I mention?
well, it's all about the response, right? So the response is a category, right? Okay, so which variable would best explain or predict the other variable? Okay, so you're thinking the electives are predicting the core the best?
What about music?
The relations with the core classes. It comes first. I think it's a, do you call that graph?
You don't see a correlation? Well, I will point out music and PE are pretty similar across math and English, but art, interesting, art is more favored in the English side. Foreign language is more favored on the English side. Technology is favored on the... So do you think that the core is predicting the elective or that the elective is predicting the core? I think the core, math, is predicting technology, right?
Yep.
English is predicting higher with art. higher with foreign language, which honestly, that kind of makes sense, right, when we think about that. But notice it also says would best explain, so we are seeing the core class predict the elective. Now, that's also just a prediction. We're going to get to some more of it in a second. By the way, based on the unit we just finished up, what's another way that we could describe the core class and the elective?
The core response.
There is a correlation, but which one's the response then?
The response would be
The elective.
The elective class is responding to the core class, which would be my explanatory. Notice does it have to be causation to have explanatory and response? No. There's still a correlation, there's still one explaining the other, but I would have to do a what to determine causation?
Experiment.
I would have to do an experiment, I would have to have treatments, okay. So number 10, how do the bars, okay, so now we're introducing something new. A side-by-side bar graph, that is also going to be called a comparative bar chart, okay? Or comparative bar graph, okay? So what is happening in this comparative bar chart, the side-by-side bar graph over there?
It's comparing the core class and source.
So we've grouped it by the core class, my predictive variable, my explanatory variable, and then what do I have going inside of that math right here?
The elective.
So I have the electives, right? And the what are the electives?
No frequency.
Is it a frequency?
Relative.
Okay, so this is the percent of math who picked each elective. Notice that means if I add each of these together, what should I get?
100.
Just for math, 100%, right? So what kind of relative frequencies do we have inside of here?
Percentage.
Those are percentages, yes, but what type of relative frequency? Conditional.
Conditional.
Not both of them, because remember, this is supposed to add up to what? 100. That's just looking at the math. Notice over here when I look at this math, because that's what this next question is asking, how do the bars in the side-by-side bar graph relate to the bars in the segmented bar graph? What is this supposed to add up to?
100.
And what does the segmented bar graph add up to?
100.
100, right? So, the segmented bar graph, which we're going to have to end here because that bell's going to catch us, but the segmented bar graph shows the sum of the, which relative frequencies? Conditional relative frequencies. All right, we'll pick up there tomorrow. For those of you who are gone tomorrow, please watch that video ASAP. When's our test? Monday. If you want to ask questions about the AP free response questions, you can ask that at the beginning of class tomorrow. If you want to send the question in for a friend, or with a friend, you can do that.
What about the RG?
Wait, you said
Totally forgot to do that? I'll email it to you. Say again.
what did you say?
If you want to send in a request with a friend to go over one of the AP free response pieces, let me know. But I'll post the solutions to the AP free response questions on Schoology. And if you want to send a request in for a friend so that I go over it so I can record it, send that in with a friend. You can also email me, I guess.
What do you mean we should?
Yes, right. So remember, I just have to email it out because. You too. Hi, Candy. Yes, Ian.
I guess it's getting like asking them for a friend.
I'm listening, Ian.
Wait, hold on, you ready?
So I wrote
We're doing it, man.
what,
We're doing it.
What do you see?
see, I wrote treatment. I just wrote over a green.
Okay, that's what I thought. Because I gotta be able to see when you actually wrote. The whole
Is
blank.
this still gonna be an I?
I will look at it again, because I still have to put those scores in, so
Is this
I'll
thing
look at
still
it. But
recording?
if you write over it in green pen, that tells
Oh,
me
yeah.
you had to
No, no,
correct
no,
it,
that's
right?
the only reason I did it was because